Okay, good morning, everyone. I am going to be starting on our first online lecture, and it is going to be covering Chapter 5, Section 2, which is logarithmic functions and their graphs. Today, we're pretty much just going to give you a little bit of intro on logarithmic functions, give you a couple of rules about them. As I had said in class back when we were still meeting on a daily basis, logarithmic functions are the inverse of exponentials. So they're a pretty important tool that we have to work with exponential functions. These are the objectives that we're going to cover in this chapter and section. Today, we're going to recognize and evaluate logarithmic functions with base A. That probably doesn't mean much to you yet, but hopefully after listening to this will make a little bit more sense to you. There's a lot of math jargon on here. I like to try to cut through that a little bit and just have you focus in on what's really important here. And this line right here that I'm underlining with my mouse cursor is the one that you want to focus in on. I would write this one down in your notebook if you are taking notes, which I would, just the same as if you were in day class. I also, whenever we are normally in school, have you all make note cards and have you write down all of the logarithmic functions on a little index card. And at the end of this unit, I would allow you to use that index card on the test. I would probably still advise you to make that little index card because as we move through these sections, it is very handy to have all of the log rules in one place so you're not having to flip back and forth through your notebook to find them all. So this particular log rule right here is, in my opinion, the most important one that you're going to learn, which is why we're learning it first. But that is how to take an equation that is in logarithmic form. You can see right here it says y equals log base a of x, and how to take it and put it into its exponential form, which is x equals a to the y power. Now, I kind of memorized this through the pattern that the letters make here, but if you notice, this is the log. This letter right here, A, is the base of the log, and it is pronounced y equals log base A of x. So A is the base of the log. And if you notice, when we go from logarithmic form to exponential form, the base of the log becomes the base of the exponent. And this almost looks like a to the x, but what ends up happening is the base of the log becomes the base of the exponent, and then the x and the y switch places. So you can see this again is y equals log base a of x, and this turns into x equals a to the y power. Now we're going to use this to do a little bit of solving. I'm going to kind of skip through this and just cut to the example problems here. So this is example 1. I'm going to have you evaluate each logarithm at the indicated value of x. So for part A, we want to take f of x equals log base 2 of x, and we want to substitute 32 in for x and then solve it. So this is the original problem that we start with. We then proceed to just substitute 32 in for x. Now, this is where the rule that I just showed you is going to come into play. When you have log base 2 of 32, we're going to convert this from logarithmic form, which is logarithmic form because it says log, into its exponential form. Before we do that, though, I'm going to take f of x and I'm going to substitute and just call it y, just for the ease of working with it instead of having to keep rewriting f of x. So now it's y equals log base 2 of 32. And again, the rule that we had a couple slides ago is that if you have y equals log base a of x, you can take it from logarithmic form and put it into exponential form, which is x equals a to the y. Pay particular attention again. The base of the log is the base of the exponent, and the y and the x switch places. So when we come back over here and look at our particular problem that we're working on, the base of the log becomes the base of the exponent. So 2 is going to be the base of our exponent, and it's 2 to the y equals 32. Now this takes us back to a problem I believe we did before we started on the student loan packets, which is coming up with what the power of y should be. And the way you use this is you want to rewrite 32 as a power of 2. So 32 is 2 to the 5th, and now you can see the bases are the same, therefore the powers are the same, and you get y equals 5. Moving on to example B, once again we have f of x equals log. Now we change the base here. Now it's base 3 of x. We're going to substitute 1 in for x, which will give us this equation right here. From there, I'm going to do the same thing as I did in the last problem. Rather than having f of x, I'm going to substitute in y. So it's y equals log base 3 of 1. Then we're going to remind you again of the rule that I showed you to start, which is how to take it from logarithmic form to exponential form. Notice the base of this log is 3. Therefore, the base of the exponent is going to be 3. And so it will become 3 to the y power equals 1, as you can see right there. And this is where we're going to jog your memory on exponent rules a little bit. And you need to remember that anything to the 0 power is 1. Therefore, y is 0. Example C. Again, same thing. We have f of x equals log. This time the base is 4 of x. We're going to substitute 2 in for x. So we have f of x equals log base 2 of x. Once again, I'm going to substitute y in for f of x just for the ease of using and solving this. So we have y equals log base 4 of 2. We're going to use the same property as the previous two examples, and we're going to take it from logarithmic form to exponential form. Again, notice the base is 4, so that it will become the base of our exponent, and it's going to be 4 to the y equals 2. From there, we need to rewrite the bases so they're the same. 4 can be rewritten as 2 squared to the y power. Anytime you have power to a power, you multiply. So this 2 and y would multiply and turn into 2y. And now that the bases are the same, you can take the two powers, set those two equal to each other, and then divide both sides by 2, and you get y equals 5 halves. The last problem in example 1 is f of x equals log base 10 of x, where x is going to be 1 over 100. So you can see I substituted 1 over 100 in for x and then proceeded to substitute y in for f of x, just like I did in the previous 3 problems. And same as the other previous 3 problems, we are going to utilize the first rule of logs that I showed you, which is how to take it from logarithmic form to exponential form. So you can see right here, the log is base 10. As a side note, if there is no base listed whatsoever, it is assumed to be 10. They actually will not normally write 10 here. If the base is 10, they leave it blank. So if you do see a log with no base listed, it is base 10. So this will turn in, the base of this log is 10. So the base of the exponent is going to be 10, and it'll be 10 to the y power equals 1 over 100. Now we need to get the bases the same, and 100 is a power of 10. It is actually 10 squared. Then we need to move this 10 up, and in doing so, it is going to make the power negative. And now you can see we have the bases matching. This is base 10, this is base 10. Therefore, y is equal to negative 2. And as I just said, the logarithmic function with base 10 is called the common logarithmic function and is denoted by log base 10 or simply just log. On most calculators, this function is denoted by the key that says log. And very quickly, I want to show you that On your graphing calculator, you can see the key right here. One, two, three, four, five, sixth key down on the left-hand side, it says log. And if you're in the home screen and you press that, you can see it comes up and says log. Okay, so the next example that I'm going to show you is how to use your calculator to evaluate f of x equals log of x at each value of x. So the first one I want to try, and I'm going to actually come out of full screen mode, is I would like you to do log of 10. So we're substituting x equals 10 in right there. Now, when you go into your calculator, if you type as I did before the log key, and you take log of 10, you can see that the answer is going to be 1. The next problem wants us to substitute 1/3, so we're going to do log of 1/3. Once again, we're going to press the log key, 1 divided by 3, close out your parentheses, and hit enter. This time we get a negative decimal. The third problem asks us to evaluate f of x equals log of x for x equals 2.5. So we'll go back, hit the log key, 2.5, close out your parentheses, and hit enter, and we get another answer that is also a decimal. The last problem we're going to do is to have you evaluate log of x as for x equals -2. And when you try to do that, type log, type -2, and you hit enter, you end up with an error and it says non-real answers, and you can quit or go to. I always like to go to, and it just shows you that that's the problem. Um, what what is occurring is that the input value of -2 is actually outside of the domain of x. I'm sorry, the domain of log of x. We have not looked at the graph of log of x yet. We are going to do that in subsequent days in this section. So this will make more sense to you in a day or so once we get to that part. But just understand that anytime you try to take log of a negative number, you will get an error because you cannot log negative numbers. All right, that concludes the first online lecture. If you would like to try some practice problems, I would like you to work on page 380 and numbers 7 through 18. They go right along with exactly what I just lectured on. Hope you guys have a good day. Please feel free to email me if you have any problems or questions on these these practice problems. Take care.